Hello, my name is Eduardo Navarrete Baltzar, and this video is about the research project we carried about in the Learning Unit Research Methodology, and the name of this project is Vehicle Traffic Detection and Analysis System through Computer Vision and Convolutional Neural Network. The research line is Artificial Intelligence, Decision Algorithms, and Artificial Vision. My advisor is Giovanni Garcia Jaime, and we will begin with the slides. So now, traffic measurement. Traffic, it's essentially to measure it to question, adjust, evaluate, and regulate vehicle activities and the operation in the city. With them of improving control by identifying actions, strategies, and finally results. So then we have the artificial vision that it comprises a set of techniques and process for the acquisition, processing, and analyzing of images of the real world by means of a computer. This is high complexity is due to the inherent inverse nature. So for this work, it was shown that for the recognition of a car by a convolutional neural network, the image to be processed must be in a grayscale, so that the computational cost is not so high. There are techniques object tracking, so like optical flux density that determines the direction vector of a pixel. Then we have the optical flow rate, that the tracking of the characteristic points, Kalman filters that determines the position of an object, the maximum variance that this determines the peaks of a density function, and the single object location that objects tracking in frames that are subsequent. And for last, we have multiply object localization that identifying rectangles belongs to the object. Then we have the general diagram of moving object detection system. So first we have the illumination invariant monitoring detection, and so where we can get the image traffic. And then in point 2 we have the object feature extraction, so we can so the algorithm can detect or extract the feature of the a car. And then we have the neural network classification that it determines if it is a vehicle or it's a human. So we have what is convolutional neural networks. To take input of image and return detection within the image, it mimics the visual cortex of the human eye, so making multiple copies of the same articulate neuron, and then this allowed it to be composed of multiple neurons and computationally express large models as a relative low number of parameters. So for the vehicle classification, we have YOLO models that are based on artificial neurons. They learn to perform assigned tasks in a supervised manner using labeled data as input. For the formulating the research problem, we have that traffic on the roads is very common problem in growing urban areas by due to poor planning of the streets, avenues, etc. The congestion of the roads affects both cars and pedestrians. to the invasion of the cars in the pedestrians crossings, equally causing effects on the environment, and as well having many problems in persons that or drivers that are in the traffic. Focusing on a certain area, we select the El Dorado zone in the center of Tlacomulco. That is a problem of traffic congestion, and this will be the area to study. The core question behind how to detect vehicular traffic in the Dorado Tlacomulco area using artificial vision. Our secondary questions are: what variables will be considered for an algorithm to detect vehicular traffic? So, what will be the tools to analyze vehicular traffic, and how to measure the effectiveness of the proposed algorithm? For our general objectives, we have to create a system to the analysis of vehicular traffic from an object classifier for the generation of automated reports based on artificial vision and neural networks. In our specified objectives, we have to perform an analysis to identify the elements involved in a traffic image. Then we have developed the algorithm for a convolutional neural network using Python. As well, we have trained a neural network and determined the percentage of error between the real data and the data generated by the network. Also, develop a model to generate the reports of the number of cars transited per hour. In the justification, we have the develop of this system will be allowed the generation of traffic reports in the area delimited as El Dorado. It will be possible to observe the hours with the highest flow of vehicles in this area. These reports will be delivered to the corresponding authorities so that they can make a plan for the optimization of this roadway. Also, the implementation of optimization of signaling devices or for the better traffic control impacts. So, technological impacts, we have a new way to detect and analyze the traffic in different areas. Adaptations can be made in the future to implement digital traffic control devices. So in social, we have a feature transfer of the reports generated by the system, that this will allow the analysis of the vehicular traffic for the optimization of the streets. And the hypothesis, we have that if an artificial vision algorithm and the convolutional neural network are implemented for the detection of road traffic elements, then the vehicular traffic can be estimated with 18% of efficiency. And now in the flowchart, we have the start, then the state of the art review. So then we have the collection of traffic videos. Then we have the video preparation, that is the extraction of the image traffic that will be processed by the classified uh, network. And then we have the the algorithm development of artificial vision. So in this part, we need to review if this detects objects. If it not detects the objects, it will be adjustment. So when it can detect objects, it's going to pass to the classified convolutional neural network. And then here is where I'm going to ask if the automobiles are rated at the 80% of efficiency. If it not, will be this percentage. There will be two adjustments. If we don't get that adjustment of from that rated at 80%, like 79, 78, we will work with that percentage. So then if we have this efficiency, it's going to report management with the data collection, and it will be the counter of the type of vehicles that transited in that district, and that is the end, the timeline of the activities what we are going to do in the project. That will be all for the presentation of the research project slides.